Hi, everybody. Welcome to How to Unlock Your App's Potential. Want to thank you all for attending the session. It's the first time we're speaking here at DroidCon, so we're really excited. Let me get started. So first, a couple of introductions. My name's Mike Genewich. I'm the one on your left, not to be confused with Praveen Chavan, our engineer. So I've been in the industry for about 25 years now. Started as a programmer, got lobotomized, moved into product management, have been there happily for the last 15 years at Qualcomm. Praveen, you want a quick introduction?
Yeah. Can you guys hear me? Hey, I'm Praveen. I have about 20 years of experience in multimedia software development. So I'm a software developer at Qualcomm in the video software team. My focus is developing features to improve the video experiences. And today I'm going to talk about how we can make that available to you as a developer.
All right, great. So how many of you know the company Qualcomm? Just quick show of hands. Oh, that's actually pretty good. That's pretty good. So back when the LA Chargers were in San Diego, when I told people I worked at Qualcomm, everybody thought the stadium. And although I might look like I'm slinging peanuts and beer or turning the turnstiles, had to quickly explain to them that Qualcomm is actually its own company here in San Diego. Technically, we're a fabless semiconductor designing chips for all sorts of applications. But that doesn't really tell a room full of developers very much. In plain language, we build hardware and software. And we put that software into mobile devices, automobiles, IoT devices, and other bespoke electronic devices. We're also a key developer and advocate for standards. That's maybe how many of you know of Qualcomm as kind of pushing the edge of connectivity in terms of first 4G and then with 5G, and also in the areas of multimedia and camera performance, where as you can see, we were one of the first mobile ISPs to incorporate 4K and HDR video capture. Building chips makes us a key software developer. For every chip we produce a board support package or BSP, and we provide that to the OEMs. That becomes a basis for their device. So we're really there from the start in terms of getting into the device and being represented, and our software represented as part of the device. A few highlights just to kind of give you a sense of who we are. So we're based in San Diego. We were founded in 1985. You can kind of see the startup picture over there. That was a time when probably most of your parents or grandparents wore ties to the office, not very much what a startup would look like today. We have large centers around the world, including in India and China. About 50,000 employees, give or take. And then we're in about over 1 billion active Android devices, as measured by Google in the Play Store. So if you step outside of that and look at China, China obviously doesn't have GMS applications. We are also in, let's say, a few 100 million devices there as well. Does anybody work, or is anybody's application hosted in China by a third-party app store? All right. So it seems like it's mostly GMS market specific. Well, that'll be very important. Most of what we're going to talk about is focused on standard Android APIs, so that's a good thing. One bit of notoriety is we were actually a part of the first Android device that went to market. This is the HTC Dream that launched in 2007 or 2008. 2000, wow. So back in 2008, we worked closely with Android and this new group within Google to develop the basis for what Android is today. And we've continued to kind of progress with that and build chips to satisfy the mobile market. We also are becoming more and more known for Snapdragon. So as you can see the Snapdragon logo here. Anybody in here follow the EPL or the British Premier League? You'll notice that next year we're going to be the front logo for Manchester United. I don't know if that's a good thing or a bad thing, but we're excited about it. We've had a long partnership with Manchester United, and now instead of the team viewer, you're going to see Snapdragon. We're also fairly well known for 5G. A couple years ago, there was a lot of controversy about 5G going on, and you might have heard China and Apple and Broadcom and all these different things. It kind of brought our name notoriety up a little bit. Obviously for premium Android devices, so if you have a premium Android device in your pocket, chances are it's running a Snapdragon processor. We also are increasingly becoming known for Snapdragon XR and AR applications. So we have our Snapdragon Spaces folks who are presenting, I think, on the opposite wall. Stop by, take a look at what they're offering. Really interesting stuff. And as well as XR, we're moving more and more into auto. So your automobile is now becoming more of a connected device, right? Sort of where we started. Qualcomm, the name Qualcomm came from the term quality communications, which is a name you might expect from a bunch of engineers. It's kind of morphed into a variety of different areas, but we're really excited about all of the things we're doing here in Android. So what are we doing here today? I think we're here to promote our Android on Snapdragon developer website. So this website, we launched it a few months back. It's very organic. It's coming up from the start, from the bottom. But it's meant to help developers learn, use, and integrate functionality into their devices. That's simple, right? We're admittedly just getting started. The plan is to provide a continuous stream of blogs, articles, documentation, expanding upon the standard Android API reference documentation to provide developers with a little bit more insight into how to use the code, right? We are an Android-first shop, which means that our APIs are focused specifically on trying to enhance the standard Android SDK. We're fully aware of the fragmentation. I don't want to start talking with you guys about it because I'm probably going to hear a lot about it. But we want it to be standard in Android and available on the platform in order to make use of it. So why Qualcomm? That might be a question in your mind. You guys are an SoC provider, right? You're someone building the chip. Actually, the reason why came from dialogue with third-party app developers. So we were talking with them, and they were expressing that there's a gap sort of in between what the SoC and the BSP offers and then what the OEM skins as their device. And they said, you're kind of in a perfect situation to provide developers with a little bit more insight into what's happening below the covers, right? OEMs are focused on their UIs. They're focused on their applications. They're focused on making the best possible experience tied to their brand. We're agnostic, right? We're looking at just trying to improve the overall experience that a user has when they use their Android phone. So that's really, really what our focus is here. We work closely with Google on Android design, API design from the start. We are currently in the process of working with Android 15 API design coming next year. It's a good position to be in to figure out the most power and performance efficient way to build an API or to build the BSP. And so we work closely with them on an ongoing basis to do that. We have for decades worked closely with OEMs. So our bread and butter is working with Samsung and Xiaomi, and in the past, LG and HTC. And that has been really great for them to expose the best possible experience you could have with their application on their device. What we want to do now is turn that to the application developer. Many of these APIs that we've exposed already are available on device today. Many of the optional APIs that are in the Android API are available on our platforms today. So we want to make sure developers understand that there's a richness lying underneath the OEM brand that you can still get access to. So let me talk about this design really simply and quickly. So at the top level, we have sort of like the top of the food chain, application developers like yourselves, right? And what we're doing to support application developers is we're hosting a GitHub website, besides documentation and API references and blogs and everything that you can get on the Android on Snapdragon website. We're also hosting Android on Snapdragon GitHub so we can put code samples out there, right? So we can give you additional documentation. So we can feed use cases that sit above a standard API reference and really kind of express how to do it. Sort of here in the middle, again, more of our bread and butter. What's important for OEMs and what's important, I think, from a lot of developers is to limit fragmentation. What we have is a Qualcomm Single System Image, or QSSI. You've probably heard of the Google GSI. Maybe you've heard of the different SI images that are coming out as part of the different OEM packages. Our QSSI provides a single common Android API across all of our platforms. So from the most premium tier device down to the most mass market device, you're getting the same set of Android APIs delivered to the OEM to be delivered through the OEM's device to the developer. This provides great leverage because we like to think that if you write it and do the application for a premium tier device, it's going to work seamlessly across the portfolio. Included in our QSSI image are Android-specific extensions. So these are Snapdragon vendor extensions which are made available, again, for a long time to the OEM, and now being made available and exposed through documentation to developers. So you can make your application that much more rich, or what I like to call make it look more native than a simple third-party app. And then lastly, the Snapdragon vendor software. This is, as you can imagine, the BSP image that includes modem, Wi-Fi, connectivity, everything that's required in order to make things work. 1 minute on other things we're doing, and then I'm going to hand it over to Praveen. So we have an extensive Qualcomm developer network at developer.qualcomm.com. It includes a variety of different programs focused on specific areas. So AI, kind of hot right now, right? Go there and you can learn about the AI Engine Direct, which is a way to tunnel your AI application directly to our hardware, our neural processing unit, to get the best possible performance per watt. Our Snapdragon Spaces SDK, please go visit our booth here. You can learn all about how to layer XR capabilities on top of your application. And then if you're into gaming or have worked in a gaming company, you can look at our Qualcomm Adreno GPU SDK, which provides tools and libraries and everything to build rich and immersive 2D and 3D gaming. On the right side is our open source commitment. So working with Android, we are a huge provider of code to AOSP, including to kernel, right? So the entire Android stack, we are making large contributions to it in the open source space. You may see us there. And then our main conduit for engaging with the open source community is through Code Lenaro. If you do Google search for Code Lenaro Qualcomm, it'll bring you right up to the page that has all our projects listed. And then, of course, supporting those with developer platforms. So on the right-hand side, you'll see our HDK, which for about $1,500, you can get a reference design of our latest chipset with a display so you can start developing on it. You can see our watch platform, a little bezel right there, you can kind of see, which can be used in order to build applications for the wearable space. And then again, if you go over to our booth, you can actually see the XR device. So what we wanted to do today is just express to you three ways in which you can make use of the Android on Snapdragon website. I'm going to hand it over to Praveen. He's going to walk you through it.
Sure. Thanks, Mike. All right. At Qualcomm, we have been, like Mike said, we have been working on implementing a lot of features to improve the user experience. And these were mostly available to the native apps or like the first-party apps because of all these partnerships with the OEMs. But they never went into the hands of a developer. So what we've been trying to do is focus on getting these features out to the developers for basically getting these into some of the third-party apps to be used in some creative ways, right? But again, our focus is to get those features available in the most efficient way is to get those in the Android SDK APIs, because nobody likes using some custom SDKs or doing something fragmented, right? So that's where we are focusing on, and for that, I have an example for you. But having said, there are a lot of features that we have that don't necessarily are part of Android API yet. They're still in the pipeline because it takes a while for these APIs to make it to the upstream AOSP because there has to be some standardization. But while we wait for that, there is a way in which using these vendor extensions, you can tap into the benefits of unlocking these features and using those creatively into your applications to build more compelling user experiences. So I'm going to talk about that with an example. Then finally, I'll also talk about briefly the work that we are doing with the upstream communities, like the Android Jetpack libraries and things like Exoplayer. I'm not sure if you guys are aware of that. So I'll walk you through with an example of how you can leverage some of the community projects into your applications to build exciting applications. All right. So, well, for each of these, I have picked an example. And since I'm a multimedia engineer, all my examples are highly biased towards multimedia. Please bear with me, but that doesn't mean that we are just focused on multimedia. But I do have links whenever I walk through these examples, I do have links with additional resources, learning resources, which you can always refer to see what you would be more interested in. All right. So for the first case, talking about the Android SDK APIs. So how many of you know HDR? Well, yeah, I mean, it's quite popular. So it's a high dynamic range. It's a technology that allows you to improve the or enhance the viewing experience. Well, I don't think this is an HDR display, so maybe you can't really tell. But
It's a little bit.
a little bit. Okay, from here I can't tell at all. So, well, no prizes for guessing. The left is the HDR. But as you can see, I mean, what HDR does is basically adds more range to the luminance so that you can see darker is dark, brighter is bright, and it adds a lot more color so that you can perceive like real life viewing experience, right? But it does it with a few tricks like increasing if it is a digital signal, it adds more bit depth so that there's more precision. It does some things with the gain map and with the gamma curves to basically embed that information, right? We're not going to talk about that. That's not the agenda today. But I'm going to show you if you have let's say, a use case where you deal with video. You capture the video or you store it and then render it. I'm going to show you with some simple steps how you can today upgrade your application from SDR to HDR, right? By the way, let me ask you this. How many of you have a video in your application? Cool. That's good. So let me see if I can pull the pointer up. It's just easy. Is that visible? OK. This is just a code snippet. If you're aware, if you're doing some sort of a camera capture today, so there is a camera to API. Yeah, there is this API called request available capabilities. By the way, what I'm talking about here is actually part of the Android API, right? So you just use your Android SDK and make sure you're on the latest API level 33. Then you can actually access these APIs, right? So you must be already familiar with the camera characteristics, which is basically used to discover the capabilities of the device. So before you go and try something, you've got to make sure that this feature is available on the device, right? On API 33, Android defined the dynamic range 10-bit profile support. If you query and if the device supports returns true, that means the device is actually capable of capturing a 10-bit video, right? Now, if that is true, then you can go ahead and query the dynamic range profile. So range profile is nothing but, like I was saying, there are different technologies to do HDR. So there is HLG, which is a more baseline. And then you have HDR10, HDR10 plus, which is a little bit more advanced. So you can query the device and see what HDR profiles you have, right? So for this example, let's limit ourselves to HLG10, which is the baseline. Okay. So moving on, after we discovered that this device does support HDR, the next step is really simple: is to set the intent to the camera, saying I want a dynamic range profile, right? So in this case, again, we'll stick to HLG. So in the output configuration, let's say you have a surface where you want to stream the camera images. On that surface, for the configuration, you add a dynamic range profile by using this API. Okay. Once you do that and you create a camera configuration session, then start the capture session, the camera starts automatically streaming HDR images instead of SDR. Okay? So what you got is you upgraded your camera side to now start streaming HDR. Right? So moving on, this might seem a little busy, but this is more mechanical, so bear with me. So if you have done a video capture and a video recording in your application, then this will be familiar. So there is a class called the media format, which is an Android API, where you bundle all the required configuration for the encoder. So when you encode a video, you've got to tell the encoder, hey, I want this to be encoded as 720p or at 1080p. I want the encoder to do certain bitrate, like 10 Mbps or 20 Mbps, right? So all those configurations are added into the media format. So what we are doing differently here is really telling the encoder that I want to encode this video as a 10-bit video. And to do that, you specify the profile for the codec. So let's say if you're using a HEVC encoder, so the standard defines a 10-bit profile. So you've got to set that profile, right? And there are several color tags that you need to add. Like I was saying, the way the HDR works is it actually converts a linear signal into some sort of a tone-mapped signal. So you need to specify whatever the spec says. For HLG, it is HLG. And just as an example, I've shown if you want to use HDR, then there's a different profile for it. Okay? So it's just going and setting all these keys into the media format. Okay? So moving on, once you have created a configuration that you want to encode, that's your desired intent. The next step is really to go and create an encoder for it. Okay? So the way you do that is typically you would go and start scanning for all the available hardware encoders on the device, and then you try to match and see the capabilities of that encoder. But instead of that, Android has a neat API here, which I'm showing is the media codec list. So this has a find function where you can give the intent and say, this is my configuration I want to encode, and this API will go find for you the best encoder on the device. Okay? So if you happen to be on the Snapdragon, then you will get our HEVC hardware encoder. And then you create the encoder, configure it, and start streaming. Effectively, you have converted your application now from being a SDR capture encode session to a SDR. So these are just the simple steps. So just to summarize, again, if you have a SDR workflow in your capture, then you can use these APIs to make it HDR. And what HDR does, we saw. I mean, it enhances the user experience. So
just to state the URL on the bottom actually includes, it's the blog post, it includes all of this code. So no need for you guys to write it down if you want. Go ahead and visit the blog, get it there.
Yeah, there's additional details there. Yeah. Okay, so I guess we can move on. So that was one example where these features were actually sort of not available to the third party, but we did work with the ecosystem to make these available in the Android SDK. So now these are like the first-class APIs you can go ahead and try. But having said, on the platform, on Snapdragon, we have been investing into a lot of silicon and the software to bring some compelling features to the end user. And these were available to the first-party apps. So when you open the latest and greatest GS Galaxy phones and you use their camera, you do something, and then if you use the same Android API and write an app, you may not necessarily get the same user experience. So we're trying to beat that. However, like I said, getting an API, getting a feature into the Android API is our vision. We're getting there, but it just takes time. Any standardization takes time. So if you want to try any of our application, any of our features in your application, and basically unlock some of these hidden features and bring more sort of compelling user experience to your app, then we highly recommend using the Snapdragon extensions. Again, we have a lot of literature on the links that I'm going to show, but let's just dive into one specific example here. Again, I've picked a video example, but let's say you are encoding a video, right? Typically what happens is if you start encoding the video at a lower bit rate, then you would start seeing some sort of artifacts, which is given, right? Now, you wouldn't care about the bitrate too much if you're just encoding and saving the files on the disk, but that's rarely true because an app, you would like to share the video with, over the network, or maybe even stream it. And when you reduce the bitrate, it doesn't matter what phone you're running, Android, iOS, all the encoders do the same thing. They start showing some sort of blocky artifacts, okay? But let's pretend that your application has this additional information where the objects are, where the key focuses are. For example, you could be having like the faces data, right? Which you could be getting from the camera faces API. There's a face statistics. Or you could be using MLKit, or you could be using MediaPipe, which is yet another way to get the faces data. So if you have that information, the region of interest encoding feature that we have here can actually selectively maintain the quality in those focus regions while still maintaining a low bit rate. You see, it's like a trade-off. Okay, let's try to see. Okay, what I'm going to show you here is in this example is, let's say we have a face data which is a bounding rectangle over this person's face. Then we'll see how we can tell the encoder this information that, hey, here's the interesting part in the image, and make sure that the quality in this region remains good, right? So we can do that using simple API here, which is an extension API. Like I said, some of these APIs, or rather all of these extensions are exclusive to Snapdragon devices. But like Mike said, If you have a premium phone, then there's a very high probability that it's running Snapdragon. However, your application has to be more generic. Make sure it works on all devices. So there is an API that was introduced in API level 31, which allows you to check all the supported extensions on the device, okay? So again, if you see, the important thing here is I'm not importing anything custom. It's just working off of your Android Studio, right? It's just I'm importing the standard classes, okay? So really what this code is showing you here is figuring out if this is available on the device, okay? Again, this link here, I hope you guys can see, gives you much more resources and other features. If video is not your thing, I mean, you don't want to add video, and you have no intentions of doing that, there are several other features that you can actually explore, okay? The next step is really to tell the encoder. Like, remember we just saw the media format? Maybe I'm familiarizing you guys with the media APIs. So there's a media format, and we were packaging like bitrate and the resolution for the encoder. So we are going to add one configuration to the encoder which says use the region of interest encoding, okay? Once you do that, the next step is really to give those rectangles or the regions to the encoder using this API. So you set the region info, and you set the rectangle info here. But additionally, there is something called a QP bias. So just think of it that bias is the strength of the compression. So higher the value, the encoder is going to compress that region more. It's going to look more choppy and blocky, but it will also save the bits. But our goal here is for that specific region to increase the quality. So we're going to give a negative bias and tell the encoder, hey, increase the bitrate slightly in this region, but make sure that the quality is better, right? So that's the trade-off we're playing. So using this API, you can set that. And by the way, on Snapdragon, you can set up to 10 rectangles because you may have multiple faces being tracked into an image, right? And each of these images can have a different QP bias based on which person you like. You can give more bias. But overall, the encoder is going to get that information along with every input buffer, and then it's going to process that, okay? Now let's look at the end result. Again, I'm not sure if you can make these subtle quality differences from where you're seeing, but this is just a zoomed-in version of a still from a video that I captured. Again, it was encoded at 720p. The same encoder, it's the same bit rate, it's the same frame rate, but if you can notice that this is the general video, how it would be encoded. But with this feature, if you see, some of the features look more sharp, they look more crisp, and you don't see those artifacts in there. So this is a big deal. I mean, if you're an application, again, summarizing, that needs to encode video at a really low bit rate, so you can use this API to essentially give a better user experience, okay? So we don't have much time. I'm going to run to the next one quickly. If you happen to use any third-party support libraries like Exoplayer, do you guys know what Exoplayer is? Yeah? For folks who don't know, I'm pretty sure you know what is YouTube and Netflix, right? So these popular apps, they do have a common player that they rely on, which is called the Exoplayer. I'm going to show you a case study where our audio team worked with the Exoplayer team. We partnered and enabled a feature called offload audio playback. Now what this does is, instead of, if you notice, the typical decoding chain is, there is a media codec which actually takes the compressed stream, decompresses it, and the uncompressed audio samples, like the PCM samples, are then rendered through a audio track pipeline. But if you use a offload audio, it's going to send the compressed samples directly down to the audio track. So what it means is you save the decoding time on the CPU, but rather you send it down deep into the hardware, where on the Snapdragon devices, we have a digital signal processor, which can run audio algorithms at the fraction of a power, right? So the end result is you'll get a better power profile. The code looks as simple as that. So if you are using Exoplayer, when you build the Exoplayer to the builder, you essentially specify a offload listener, and you say, set offload enable to true. So this listener is just to get some notifications. But all that you need to do is call this API and say offload enabled. So what this will do is bring down the power without you writing too much code, because we have already optimized this in the Exoplayer library, right? So 13% is a big deal. I mean, if you're listening to an audio, this can extend your battery life for at least a couple hours, I think. So yeah, that's pretty much what I wanted to summarize. So I'm going to have Mike here. I hope you got to learn something from these code samples.
Yeah, it's all for him. So this is something that we're really proud of because in our own way, we're trying to improve the experience for users and the experience for app developers without interfering, right? We want to do things underneath the hood that just make it better, right? An example here. So in conclusion, please, I noticed a few of you already going on the Android and Snapdragon website. Please do take a look at our blogs, go to the developer programs, sign up as a developer, and come and visit us at Snapdragon Spaces. And I think we're going to save a couple minutes here for Q&A if everybody has any questions.